be talking about the concordance crosscap number of a knot.
Thank you very much. I would like to thank the organizers for giving me such an opportunity to talk here, and also I would like to thank all the people here to come back and attend my talk. It's really late. I have good news. That is, I will keep the time, okay? So I will start. And I think, so concordance, I think Professor Cantor, he introduced something, the same category of conception in his talk, so, but later I will remind you again. So first, anyway, let me start. So we have a knot K, which is embedded in the 3-sphere S3. And it is a knot. And this knot K bound surface F, and bound surface is in the 3-sphere, and also the forward D4. And this surface is orientable or non-orientable. And we know that this knot K can bound many different surfaces, right? Either in 3-sphere or the forward D4. And we can, so if in case F is orientable, and then we can define the knot genus G of K to be the minimum of the genus among all the. So this F is embedded in S3 and orientable, and with the boundary K. So this F is embedded in S3, and if we consider the surfaces embedded in the B4, the forward D4, we have 4-dimensional genus. We denote it by G star of K with the minimum. G star, still G of F, and here F is B4. Sorry, I should use D4. And here the same, orientable with the boundary K. So in case F is non-orientable, we have crosscap number, gamma of K. We define this gamma of K to be the minimum of the first Betti number of all the non-orientable surface bounding the knot K. So here F is in S3 and non-orientable, and with the boundary K. And similarly, if F embedded in D4, and we have 4-dimensional crosscap number, F is in D4, and non-orientable, bounding the knot K. So we can see the relation between the two different versions of genus and the crosscap number. So we know so clearly G star of K smaller than or equal, and here we have gamma star of K smaller or equal to the gamma of K. And so these are two versions of genus and crosscap number, and we have a third version of knot genus and crosscap number defined from a different viewpoint, which is a knot concordance group. And so first let me remind you the definition of concordance. So we say K0, two knots K0, K1. If we say K0 is concordance to K1, I denote by this. If K0 and K1 co-bound smoothly embedded annulus, so with in S3 cross the interval with K0 in S3 cross 0 and 1 embedded in S3 plus 1. So this is a concordance, not concordance. And we know, we call K is a slice node. If K is concordant to the M node, then we can define the concordance genus. We denote it by GC of K to be the minimum of the genus in node K's concordance class. And we define gamma C of K. We call it concordance Crosscap number, and this is our concordance Crosscap number. And this is defined to be the minimum of Crosscap number in K's concordance class. So I have introduced the three different versions of node genus and the Crosscap number. Do you have any questions by now? Okay. So actually here, by convention, we define, so give a node, we denote it by U. Gamma of U, by convention, is defined to be 0. Okay. So now I want to see the relations between three different versions of genus and Crosscap number. And we have, so G star of K, smaller, so they have this relation, G, K, and this is a non-full version, we have gamma star of K smaller than gamma of K. And so let me show why this is true. And suppose we have, this is our node K, is in S3, this 2 point K. And this is S3 plus 1, and this is K1, and K is concordant to K prime. And then, so in this case, there's annulars. We call it A. And this K prime bound the surface F in S3. So this is the surface. And we have annulars here. And then A unit F is the surface in the forward D4 and bounded with node K. So then we know that the concordance genus and the Crosscap number is obviously bigger than or equal to the 4-dimensional version. So here this F is not necessary to be, so it can be unearthable or non-unearthable. So this is just to illustrate this relation here. And if K is a slice node, and we know that GC of K is equal to 0, and but GK is usually not 0. But we have G star of K is equal to. So in this case, we have this one. And so in this case, we may think whether this G star of K and GC of K the same thing or not, right? So for the slice node, they are the same. And then there is such a question by Gordon, asked in 1970s. So whether there exists node K with